What is feature engineering?
To drive
Finding
value from
inputs
the
that
model.
can help you find right patterns. We said models are nothing but patterns or some kind of a math equation which helps you do prediction. What are transformers? It's deep learning for language. What we said is that, hey, we can automate the process of learning by putting some things called neurons. If we connect everything to everything, today I will talk about, I will touch on everything. I will touch on how can we, what are LLMs, how do they think? Okay, I have some examples. I'm going to talk about, this is the first time I'm doing this, by the way. You've not seen this, I've not done it. Assume that all of you know what neural networks are. Just to revise, what we said is that, hey, we can automate the process of learning by putting some things called neurons. And then if we connect everything to everything, we can call it a fully connected forward feeding network. And in this, these were the weights. And then we added a bias in the end. And then for each one, we created an idea of lot of weights, which we can learn. And how we learned is we had movies on the right hand side. And we said, if this movie function needs to be reduced, and we came up with this fancy equation called y is equal to delta c minus l relu 6 wx plus b. Imagine we have a way to learn this by going backward and adjusting these weights and biases to reduce this loss function. And how we do it is by doing gradient descent. That was the idea. Okay. But today I'm going to talk about how we got to transformers and how they work. That's the main thing I'm landing. Why you should learn about these technical things, like we talked about neural network, even this hard equation, because I talk to my director or my PMs or my VP friends who are now VPs in different companies. And I say, what is one challenge you're facing hiring PMs? And they tell me that, Mahesh, PM is like a leadership role. And it's a huge cost for us to bet on these people because we let them lose for 6 months to a year. And our job depends on them. And one quality, especially in AI, they are looking for is that you should know what are the limitations of AI. And if you don't know the foundation of AI, which is neural network and transformers, you are not able to make the guesses, or you're either shooting too high and setting goals which are unimaginable, unattainable, or you're shooting too low that everybody is a common wisdom, and you're not able to play in the region where most of the companies need to play to succeed, which is taking calculated risk. And that calculation of risk comes by knowing fundamentally how this technology actually works. So I think I made a good enough effort to land neural networks last time, and I will try to land the transformer this time. These are the two major things that has changed or made huge impact on foundations of what you see in machine learning and AI. And they are in every network or everything that you do. These are the two fundamental things that go. Now we're going to learn transformers today. Okay. Again, I will try to see how can we land hard things and make them easy for you. Okay. So we know there are neural networks. We know how AI actually thinks or how these models are built. Can somebody tell me 4 steps of creating machine learning based systems? Let me give you 1 and 2, and then you can help me with 3 and 4. Maybe that will be helpful. Let's say first step is getting your data. Second step is feature engineering. Can you guys give me the next 2?
Model building.
Model building. Very good. Model building.
Model assessment.
Assessments. Perfect. Okay. With data, this is all the inputs you could provide. Anything that you want to deal with or anything that you are dealing with in your life, that's yours. That's the input to the models. What is feature engineering?
Finding the right set of inputs to drive
Finding
value
inputs
from the
that
model.
can help you find right patterns. We said models are nothing but patterns or some kind of a math equation which helps you do prediction. And this can be inputs to that, but these are maybe user defined or user created or enhanced input, which actually has a huge impact on making the right prediction for the model. Great. So we talked about movies, and we say if you want to predict movies, you can take actresses, director. All this is public information. But how a movie actor, actress, director combo score, if they have given 3 hits back to back, that finding what is that combo score when they come together will be a feature. And if you start putting that feature, whether the movie will be a hit or you will watch the movie or not, there is a high probability that if you have seen Ranveer, if you have seen Deepika, and you have seen Imtiaz Ali, then these three, when next time going to come together, you're going to watch that movie because you have watched all those three movies in past together. And that's not here, but if you can just feed that explicitly, that combo score of those directors, that when they work together, they create magic, then that would be a good example of a feature. And model
Mahesh,
building is actually finding the parameter.
Mahesh, may I just make, so this is said, and to Mahesh's point, if you're looking at predicting, and just in the example of the feature set engineering and from my past experience, if you're predicting somebody, what will be the length of stay of a patient in a hospital, if you put in demographics, age, and all that stuff, they are good indicators. But something that might be a good feature set would be something like, hey, what is the diagnosis code that individual has? If it is a heart failure versus if it is some sort of a trauma, or is it some sort of a, so all those things, they will be a feature set. And just to add on to what Mahesh was suggesting, a feature set helps us sort of amplify the signal and reduce the noise as you're sort of building the model.
Yeah, a doctor and diagnostic. There are few doctors which will be prone to keep patient like longer in the hospital, and there will be some doctors which are same diagnose, but they believe in people recovering at their home places better. And that will not be in this data. That doctor to diagnostic, you can come up with that. So I just added doctor to yours just to make it more fun. But
thank you.
That's another good example. Okay. Now model building, and then we were also discussing that, okay, now we can build model and then we can assess the quality of model. These are your evaluation. Then we also talked about that, hey, you know what? We are automating these, and neural network is a way. Instead, if before 2000, if you wanted to do machine learning, you have to hire humans to do this. You have to hire humans to do this. Human PhD level humans were needed to build all these or do all these work. But then we automated this in 2005 or so, that this part can be done by neural networks. We got those fancy numbers, which we talked last time. And neural networks, now we don't need humans. You can just try different layers. You can add more neurons. You can try different ways here to do backward. And if you do that, then this part is automated. Then we also talked about deep learning. We said in deep learning, what we have done is we have automated this feature engineering part also. So now we needed human for this part, but now we don't need human if you do deep learning. That was the big deal in deep learning, that deep learning automates not only model building, but you just give me the data, I will find what is important in that data. Can somebody give me an example of a deep neural network?
Image processing.
Nobody speak. Image processing with convolution neural network. This is what Lai Kun built. Lai Kun is one of the fathers of deep learning. And what he did is GAN, what you are putting GNNs, RNNs. So all these are recurrent. Before neural network, they added one more step. He added convolution layers. And convolution layers, basically what they do in an image, they find out where the edges of an image and what's the texture of the image, and they code that information before you hit the neural network stage in a network. You could now, what you could do is, you can actually go and now you can just load a lot of images. You still need to bring data with cat, with dogs, and then CNN will find out what are the attributes, and the neural network will learn what you call it, like a dog or a cat or a human. And now you can train end-to-end models with just data. And this was a big breakthrough in machine learning and AI. So since then, What we have tried to figure out as humans or scientists or research labs is how can we put or how can we do more and more deep learning because data we have and quality we can check. Then what we wanted to do is how can we automate a lot of things here? And we got a really good breakthrough with CNNs for images. I was checking Layakun was fighting with Elon Musk the other day because Elon was telling him that he was saying that Tesla is using CNNs for their automated vehicle or automated driving. And he said, we don't use them anymore. And then he was challenging him saying, then what do you use? Because without that, you can't process an image fast enough. So that's automation of, and it worked very well. And that created all the buzz you saw with face detection, with what you saw with uh, cameras and insights on the camera. This is all 2016 to 2020, right? But we had one thing that we were trying to solve was language. How can we understand language and detect or do translation on language, convert speech to text? And if you take them all, they were one kind of problem, which is predicting sequence to sequence modeling is the branch of ML, which is trying to solve language understanding or how to predict the next word in a language. If you want to do deep learning on that, you want to build some kind of feature engineering or some kind of model which helps you understand what is in a word. Good. So that's our problem to solve, which is we are saying we want to do feature engineering. We want to build a deep neural network which have automated a way for us to find if you write a sentence which is a quick brown dash dash, and then the model can predict in this sequence what would be the next word, right? So right now there are 50K words in English dictionary, let's say, and there are 50K probabilities of this word, right? So if I randomly go, I can make 1 by 49.9999 mistakes, right? Before I got it right. So I can throw neural networks at it. I can say, hey, neural networks, just I will tell you the word and then you learn. But there is one problem. This might work, but language is a funny thing, right? Because language have these words, and if you take that word, the word has different meaning too. So for an example, I can say, the US government has lot of interest in interest rate. You see the problem here? Let's say this word you need to predict. Now there are two interests and their meanings are different. So if you want to predict that word, if it is just word to word, you have a problem to solve, which is how can you actually go and say, I want to get this interest, but how is this interest related to what? Lot of interest, the government is more important than a lot, but this interest is more related to this lot. And if this interest is related to government, this word can be interest rate because it's an entity that you care about and the government care about. The government has interest that a lot comes from this, and maybe it's also related to the government. So you can't just take, you have to somehow figure out how to pay attention or where to pay attention because the word next word prediction depends on it. That which things that came prior I should focus on. And if I can focus that, if I can do that feature engineering, that I can decode somehow the focus that I need to make to predict the next word in a lot of words I have seen before it, if I can figure out which words to focus and which I can ignore, the probability of detecting this goes up. That's what we know as humans, right? So if you are a human, you're trying to say, hey, I'm going to solve this problem. If I can tell you this interest is more related to government and not related to a lot of people and all, then you can say, yeah, government cares about interest rate. But if I say, hey, it is about lot Then I can say maybe it's not interested in news. Then I can take it not as a noun. And when I don't take it as a noun, I have a problem that this word prediction will be wrong. So where to pay attention to the word that came before is the problem you need to solve. If you want to solve a simple problem with AI or machine learning, that given a sequence of word, find the next sequence. So you know a word, but you need to find the next one. Can we solve this problem? Okay, we're going to solve this problem now, but I'm going to tell you a story before we come back to this problem. So at least we understand the problem. The problem is we need to solve for sequence to sequence, and we need to do feature engineering so that some neural network can go solve that problem. And if somebody asks you, like, if my son, can somebody remember my son's name? He should be famous by this time.
Kabir.
So Kabir is pretty curious. We were talking about a lot of things to him yesterday. So Kabir asked me, hey, how I added to the sequence of your family? How you got me right, because he thinks he's perfect. And after me and my wife met, so let's say Payal, how he got added. There are many ways we thought about, and we did some study. Step one of that could be, yeah, you got it, Naseem, you're right. He got my hair. by the way, we have the other one also. His name is Aryan, but Kabir is more interesting because he's the older one and he's 8, so he has a lot of questions. Aryan is just getting started. Okay, so one way, let's say we want to know how we find people to marry. And then I looked at it. He asked me that question, and this was like, I was able to relate these two. Let's see if they are common. Let's see if this whole story plays out well. I told you today I'm going to play a new game. I think it will play out well. So I talked to my mom and I talked to my grandmother. She was kind enough to share how they met or how they used to find people to marry. Who should come next in your sequence came to one fact, one attention you needed to pay is who you marry. And that attention needs to be decoded, but how you decode that attention. And what I found out was that in a family, if you wanted to marry somebody, when there was no mobility, the villages used to just marry in our community, but not just in our community, which is like in India, we have a caste system, but not in our community, but almost our second or third family. It's like a cousin or a second cousin or third cousin. And you can just, if you run some kind of going back, hereditary, or if you find it, you can find the roots across those people. So what's happening is that, hey, if we got connected to somebody in past, how can we use that recurrence to find the next word or find the next person that we should let enter our family? If we had a relationship before, if his grandparents, their brother, their daughter, if she's eligible or if she's young, then we will make that as a proposal. And that proposal comes from some previous relationship. And if we can code that every time we make a new one, we use that to update what comes next. Or we use the recurrence of marriage to make predictions on what can be the next or next groom or next bride can be. That's one way to get married or find mates, which you can take with minimum risk. We call this recurrent neural networks, and they were used to predict the next word. And this model was used for ages before my great-great-grandmother to find mates or find people who you should marry. It's a one way to decode attention, because this future can be decoded to some past. And if we enter this and then use it to predict the next one, then we can somehow narrow the scope and make the prediction of the next word accurately. This was the first neural network that we used to predict the next word. Okay, so we got the next word. But there are challenges in this method. The challenge is to get to the next, you need to code the first one. So unless you code this one, you can't find this one. And if you can't find this one, then you have to do calculations. And after you go too far, you start losing information too. So it was not a perfect one. Then how we improved? And for that, what we got is we got villages by this time. Our This is my great parents. We got villages, and our community is distributed across different regions. I'm from northern part of India, so this was people marrying within like 50 kilometers. Now we have transportation. We are marrying maybe 1,000 kilometers. By the way, I can trace everybody in my family within 500 to 200 kilometers if I have to go marry just one generation above. And that's that world. These are different villages, and we kind of store their information in some kind of people who we incentivize to go from one village to another, find grooms or brides, and they come back here and they help us. This was a long, short memory of that what has happened, which family are similar, which families will match with which families on the other village. We start decoding that information in short of some memory, and we used to call them barbers or the chiefs of the one village. They used to go or remember that who is eligible here for marriage, and they used to go to the other side and say, okay, I know these will be similar to yours, and they used to be the matchmakers. And similarly, to to remove the shortcoming of recurrent neural networks, what researchers also did is they introduced something called long short term memory, LSTMs. And what they will just store what sequence you have seen before of the words, not just one. It can have a small memory which can store, hey, how the previous words are related, and ignore the ones which are not in a short term memory. And we use that long but short memory to make the prediction of the next word, which was exactly same as how my grandparents got married, which is some person have a long memory of a family's history because that was their job. Their job was to learn different families and what their values are, what what kind of qualities they have, how much of that quality they have, which could be money, which could be power, which could be good features. So they carried that long short memory, and they allowed, based on that, they created matches going to different community. And that's the same concept we use to find the next word by creating this short memory, which we can refer to come up with a new word. You go to this memory and say, hey, what should be how much attention should I pay? And it should say, you should pay attention to this one, but not this one, but not this one. And that you stored in a memory. The problem is these people are limited. There's not too many people, and one person can't store the every family hierarchy or quality key value information correctly. So it has some bias. They preferred some people. They have to remove some. And this is one person, so they have short-term memory. And when they died, we start with somebody else. And their parents did transfer the knowledge, but they could only hold. And the villages were growing rapidly because Indian population doubled, by the way, from my parent generation, my grandparent generation to my generation. So now we have so much to store. There's so much information. So this model was not working, or at least didn't work for us. So so right now we tried two things so far to predict the next word or store the attention that is needed to find the best match. And to find the best match, what are we looking for? We're looking for two or three things, right? We want to have maybe different or similar qualities. Then we want to have some kind of way to measure them. So let's say we call them their key attributes. And then these are like superficial things. This is like how tall the guy is or how tall the girl is. This is like in what hobbies they are. Do they read? Do they watch movies? These are qualities, but how much they do, which is that the second aspect of that thing. By the way, that was all arranged marriages. those whole LSTM and RNNs. But but there was a subtle thing, which is their values also, what they value. So if I could find out, hey, what are the different queries to find what are the qualities that this person has, with the right queries, I can find the keys or keys attributes or how much of that quality that person has. And then I can also somehow deduce the values of that person. Then maybe I need not to rely on these LSTMs or the barbers of my village to find a match for me. So this was the best we got before 2017. If you wanted to predict or attention, if I know the attention or if I know which words I should carry on, I could have a small memory, and the memory tells me which words are important to me and which ones are not. But this memory was limited. Hence, I couldn't do this accurately, or I couldn't do it on a large sequence. So right now in our story, what's happening is some village guy has some kind of short memory. They know who's who, and they are ready to find the mates for them or find the marriage. And they say this family is related to this family. Like we were saying, this word is related to this word. And based on that, they predicted what could be the next match, or they were playing the best role in finding the best matches across different things. But that didn't work because this was limited, and we are trying to scale it. And we came up with some things that helps us know what we are looking for, which is query, key, and values. Okay. In a person, that's what I was looking. If I can define myself or what I like, what qualities I'm looking, which can be queries, then I can find or ask these questions to somebody who I meet every day. By the way, I'm now meeting girls. I'm having a co-ed education. I live in a city. I have much more access to the things that I can pay attention to than this village barber can or this village leader can. So why not me just go with the third model, which is love marriages? And if you want to do love marriage, if you can decode yourself into some kind of embedding, if you can define who you are, because we are all unique, we look very different, our handprints are very different, we are very different, but we have to have an abstraction of us. And can we call that extraction an embedding? What is an embedding? An embedding is a representation of yours which represent you or your qualities in a way that I can learn. So my embedding would be that, okay, I'm a teacher, I know machine learning and AI, I'm from India. All these, if I can have some kind of a way to put some numbers, and then across these attributes, if you can define my embedding, where I grew up, what game I played, that's embeddings, a way to encode words into mathematical representation across different dimensions. So 0.6 can be where I'm from, how much I know about machine learning and AI, 0.7, 0.8, I'm from India. And if I do that, what it does is now I can be related in math to people who know machine learning and AI. I can be related to people who are instructors, who are from India, who live in US, and maybe who hates pasta. I don't like the white gravy pasta. So that's the thing I have. And if you have, then you will be similar. And if you love it, then you will be in an opposite plane. So if you love white gravy pasta, then you will be here. And in some plane, I will be here. And that number I can represent by negative 0.9 because I really hate it. Means I can't tolerate it. Maybe I'm intolerant to that white sauce. So I can put a high number and negative sign. That means I can deduce these two differently. These are called embeddings. Okay. So if I can be represented as embeddings, that's my first step. Okay. If I can be represented as embeddings, then I can just take my qualities or my queries around these embeddings or what I am made up of, and I can somehow multiply with somebody else embeddings. Let's say these are all the girls that I'm meeting or I can marry to. That could be around 50K if you live in a city like I lived. I was lucky enough to have that much choices. At least I thought so, that I was eligible for all the girls in my city. So I can take these embeddings and I can take one matrix, which is my quality matrix. And if I can multiply these and multiply my embeddings and find the match, that's one way I can figure out that, hey, are we related? Is there a way to do this? Okay. So that's one. So what I'm doing is I'm taking my embeddings or what I am made up of, and then I am taking some quality things that I can learn also, that what qualities I have. And similarly, I can also see how good or what is the key values on these qualities. That's the second aspect I can take. And then I can do is I can multiply my embeddings with quality and keys and take a dot product to see who is similar to me, right? So all I'm trying to find out is, hey, how is somebody similar to me? I have taken my qualities, multiplied that with my embeddings. I have taken their values also, both ways. And I have taken their keys and I have taken their whole thing. And then I can find similarities. So now, if I can find three metrics to learn, which is quality, key, and then I can decode their quality. We can call it query. We can call it key, or we can say what is the value of that query, or you can say what you are looking for. And if I can multiply these in vector, if you multiply them, if they are close by, that number is higher. And if they are opposite, that number is negative or less than 0. So then I can at least figure out who I should not deal with. If the girl can't live without pasta and I have tried 5 years of pasta, then I know that if we're going to make pasta every day, I can't live with that person. Maybe every time we are going to an Italian restaurant and just because I ate the pasta, I'm in a bad mood and she's ending up rejecting me. That means I'm not paying attention to that thing. That's one. And if you can come to quality and key, these are the two things I can learn. And these are metrics because I have many qualities. And for that, I have many keys. Similarly, so right now I have one matrix as quality and one matrix as K, and I can find their dot product. And if I run multiple iterations of that, I can also see how many times I'm doing this. Because some person I'm living next, they are living in my locality. I have many interactions with them. Some people are really cool, but I only met them 4 or 5 times. But the person you have done more interactions, they have a larger influence on that. So what you do is you divide that by a square root of how much dimension or how many interactions you have done with these people, just to give them a fair chance, because acquaintance or meeting new people and marrying them is more fun than meeting your neighbors, or just because you have lived with them, because you have seen so much. This allows me to take care of that, which is I'm just saying, hey, make sure your dimensions are hedged. So I'm taking qualities, I'm finding out keys, I'm doing a dot product of it. And then the last thing I'm doing is finding their values, which is my second matrix, which I'm trying to learn that, hey, if I can find their qualities, their key, and their values, and if there is a huge match in those, then I should focus or pay attention to those people or those girls and not pay focus attention to the people who either don't have the same query or key values or attributes or doesn't match my values. That's pretty much what a neural network or a transformer does. Transformer is a neural network that adds something very special before the neural network step. It has two things in it. It has a feed forward neural network that we all understood from last time. And before that, it has something called an attention layer. An attention layer is nothing but as combination of three metrics that you train: your query metrics, your key metrics, your value metrics, and you call it one attention block or attention head. And because you just don't want to focus on one thing, you want to have more attention heads. So you can have, hey, this is my sports specific things. This is my politics or my political view specific thing. So I can have multiple attention head or multiple values of these queries, keys, and values across different horizons in my life. And if I have GPT had 8 of these, I can learn a lot where to pay this attention or how to come up with an attention score of the words, which is the US government is interested, has lot of interest in interest rate. Let's say I'm trying to figure that out. And then I can relate a lot from this. If I take the value of this query, I can relate it or pay attention to this, but not pay attention to, I can pay attention to this, but not a lot, but not too lot. But when I go for this interest, I can pay a lot of attention to lot and the government, but not to US. And I can encode these values as QQV using this formula. And then if I can put a learning or a softmax function, which is nothing but this allows you to take all your 50K words and find out a probability which would be the next word. And that learning comes by a neural network, feed forward neural network. And attention comes by taking some assumption on these query key value and then running backward and finding out what is the right set of query key and values which gives you the best attention.
Is it possible to just illustrate the query key value with an example? Like when you say we have the politics, the diagram that you're like when you're trying to just, if you can illustrate it with an example, like what would be a query, what would be the key, what would be the value, like under when you created those various matrices rows, one example that would be super helpful, please.
Yeah. So if you go like query,
Yep.
a query in a search function is the one that you pass. Keys will be what we give you as results, and
Yep.
values will be what the content of that is.
The embedding that has been done, correct?
Yeah. So let's not go embedding, but let's just talk
Okay.
about query key values, because embedding is another like abstraction. Then the idea is that query is if I can send something, and based on that, there is those queries have some keys. You see the main search, and then you have the value of that content. And you need to have all three to make that judgment that should I click on this link?
Okay.
This is your key and this is your value. Similarly, in human relationships, you believe that basketball is important to you, but the lady has played nationals, but she played it in some state which nobody cares about. So then I'm like, okay, great. Maybe I'm not going for her. Like, let's say I was looking for a top basketball player to marry, because let's say I had this high regard for basketball because I couldn't make it in basketball. And let's say that was one of the things I wanted to pay attention to. In this example, your query is like basketball. Your key is I played national. That means you're great. But at what value, which state you played for, that also made a difference. And let's say you have like 5 prospects, then you're going after, you're taking these values and then you're figuring out where to, you are giving more attention score, which in these words, you're figuring out attention score for each word that you care about. Okay. If you can do that, the beautiful thing, I have shared a lot today. This is whole of the transformer people, which you can read and you won't understand because it's just too complex to understand. And I wish you luck now. At least let me just go back and give you what you need to remember. But now you can read a lot of stuff, which I'm going to throw at you now. And then hopefully you will be able to understand how it works. And we will continue to iterate on it. I have this as a trilogy, so I will be talking about it in next session as well. But the idea is that, hey, we need to, so what is the advantage, right? What is the advantage of this new feature engineering technique called transformers? which is based on this idea that attention is all you need. And how you put attention is you divide everything in query key value, and you find the right values of query key, which helps you find right value of attention. A word should pay backward on other words. But one beautiful thing about this idea is, which was not there in LSTM and RNNs or my village barbers, is that all of us can start finding our mates in parallel, which is this word is trying to find out this word US, how is this related? At the same time, the government can also find out what is its attention blocks. So this is the first time we could parallelize this compute. And if any compute architecture has more parallelization, we knew that we can run that on GPUs because GPUs provided us multiple cores. And if you do more calculations, you can learn faster. So three things transformer, because of their how they calculated this attention, which was very different than RNNs and others did. What this allowed us to do is it allowed us to have parallel processing, parallel compute, parallel learning. Second thing it allowed us to do is it allowed us to do scaling. This is one architecture which can continues to learn these attention. The more data you throw at them and the more attention layer you can add, it continues to learn a lot of patterns. And I will show you in a second on the screen that what I mean by that. But it has parallel processing. And third thing, which I want you to take away from this session is that because how it does that attention thingy, it is allows you to have parallel, it has scaling, and we are able to encode audio, video, and text all as a sequence to sequence problems for them to process. Once you combine these three, you got networks which are based on transformers that can grow in size and start learning a lot of things. Let me just share a couple of things. So it's deep learning for language. What are transformers? Our quick takeaways are they are allowing deep learning at scale for transformers. What is deep learning? It has attention block which runs in parallel, does scaling, does multimodal things. This meant three things: that you can add more compute by adding more layers. More layers means you can throw more data. More data means more learning. And this means that the large models we have today can do many things. And this is what I'm showing for a while now. But this is how transformers are learning new skills as you keep adding more and more parameters. This is what everybody talks about when they say law of scaling, scaling factor of transformers. That is, as you continue to increase the size of these, they are continuing to generate new insights. They're learning new patterns without anybody hard coding anything in them. And that has made this bet on AGI that first time we are getting closer to systems. If we throw more data and if we increase their size, they will learn the things which we can't. We don't even know that they can learn. And they can maybe one day become better than us in thinking, in solving problems. But the foundation is, can I pay attention, and can I pay attention to how much? And this just single foundation can help you answer questions like, why is context engineering important? What you should not do or do as a context engineering. I know Habiba want me to go for the next session. So just give me two things to land, Habiba. There is this another example. There is this, I think Financial Times did this modeling. They did a great course here, which they talked about this similar thing. I would like you to learn this. This is what I did last time also, by the way. This is how they talk about what are transformers. They show you first, we go to work. You can take the words, you can create embeddings. The work means different things in different context. This means that you can represent work as different in different context in different ways. Work means this. You can learn that and eventually come up what work is made up of. Like I created for myself an embedding this is an embedding for work, and this is how you can see it, right? So now, based on how the work is related or how the work is used in the world, like how I operate in the world, you can create a mathematical representation of this word called work. If you can do that, then you can find what is similar to that, what is a sea means, what is ocean means, how these things are related. So now you're trying to find out these embeddings, a pair of words like sea and ocean come together. So if things are coming together, if they are in math, they can be grouped together. So these are the people who are like me. They are grouped together. Either we are studying in same college, or we are going and playing in the same sports arenas, like we did humanity. So if they are same embeddings, they will be in the same plane. So you can find the distance between them and you can group them. If you can group them, then you can say, I have no interest in politics. That means interest politics no is important, and you can find how is no related, how is I have. So first they talk about the first recurrent neural network, and then they say interest is quite important. You should pay a lot of attention here. And then you say bank's interest rate rises. And now you have interest in two ways. What is important to interest? No, and nothing else. But if you take the other interest, then rate, bank, and rising are important, right? And if you can do that, then you can find out the other words which are in close by to them. And that's pretty much how it works. So now you can figure out with the same technique what it did. And if you can predict the next word, you can predict the next word. And now you can write the whole sentences, paragraphs, or whole of your chat GPT. And if you can go do it backward at scale, this is pretty much it is. So you first take the words, you create embeddings, you find self attention. And once you have, you can figure out what the next word would be. I hope this will be helpful. I have put 2 or 3 more videos, but this I found to be very simple and easy. So my goal was to land something that helps you think like I think. And then if you can read this, these two combined will give you enough. And the only thing I want you to remember is Transformer is one architecture which has a superb way to encode attention at in parallel processing. And with transformers, we can learn at scale. And it's one network which can do image learning, image specific feature engineering, text specific feature engineering, video specific feature engineering, or audio specific. And combining these three, we have something that allows us to focus as humanity on one architecture. And if you can multiply the size of that and continue to train with different kind of data, it gains to do many things. I hope we touched or scratched the surface of transformers. And if you read these or maybe read the transformer paper, you can make sense of it. Hopefully this session was useful. Use this session as a prerequisite when you go and read these papers or read anything on transformers. And hopefully together we can reach there one day. But I think this article and what I told you today should be good enough to get us started. It's little involved, so just don't worry too much. Keep these 3 things like attention is quality, how much quality, and what is the value. And if you can find those right, then you can find the attention score. If you can find the attention score, then you know which word to focus. And then you have a neural network that is trained on, if I can reduce the focus by attention, then it can be trained to predict the next word from 50K words by back propagation, which we learned last time. Okay, I'll leave you with that. If you're part of the cohort, take care, team. Bye.